Hello there. Today we'll be doing Koko eats bananas. Hey, this is going to be a pretty, binary search type problem. So let's get to it. In this particular problem, we are given these piles of bananas. They're in separate piles, and our monkey Koko can only eat, a pile of banana each time. But she wants to eat as slowly as possible, but and use up all the time as possible. So, what are the minimum number of bananas that she can eat per an hour? So for each pile we can start with one banana all the way till 11 bananas for this particular example. For this particular example, 3, 6, and 11. So piles equals 3, 6, and 11. So let's start with the index. We're going to do the index 0 through 10 for all of these because we need the left and right pointer to figure out where can we, we start from 1 to 11 actually. We don't do the index. So we have these number of bananas that we can start eating from, and we can start looking the middle item. So the middle item, this is 12 divided by 2 is 6. So by taking this middle item, we can tell if we can try 6, and if it's possible to eat all the bananas within 6. That means we can move the right pointer down and test even fewer bananas at a time. So let's try this problem. So now we have 6 bananas. So mid is equal to 6, or bananas per an hour equals mid, which is equal to 6 at this point. So by trying 6 bananas, hours taken is now, let's say, 1 hour to finish 3 bananas. Another hour to finish 6 bananas, so 2 hours. 2 hours are needed for finishing 7 bananas, and a total of 2 hours is required to finish 11 bananas. So 6 hours have taken. That's less than our needed of 8. So we can basically eat more bananas. Try to eat more bananas. So we'll move this right down below median, and let's get another one. So 5 and 1 will add them up and divide by 2. We have 3. So let's try 3 bananas. So we were doing 3, 6, 7, and 11. And we're going to eat 3 bananas now. So we eat 3 bananas. That's 1 hour. 2 bananas, 3 hours. Another 3 hours to eat 7 bananas. So 6. And another 4 hours. That will be taking 10 hours. 10 hours is greater than our maximum number of hours. So we need to move left up, and we can't possibly finish these bananas. So now we have 4 and 9. 9 divided by 2, and grounded is going to be 4. 4 is going to be our, we're going to test that. And we're trying 4 bananas now. 4 bananas, we try 1, 2, that's 3. 3 plus 2, and then we do 7. So 7 is going to be, 2 times. So that's going to be 8. So 3 is going to be 1. 6 is going to be 2, and 7 is going to be 2. So that's a total of 5. And now we have 11 bananas, and we need to do this 3 times. And so we need it 3 times. So it's going to be 8 hours taken. And that is less than a time. So that's our minimum currently. Minimum is currently 4. Min bananas per an hour. So at that rate, so it was 6, and now it's 4. So became 4. So now let's move the right down again, and it has crossed the left plane, and we're ready to return an answer, which is minimum bananas per hour, which is 4. All right, let's get to it. In this particular problem, we need a left pointer and a right pointer. So let's do that. And the left pointer is going to be 1, and the right pointer is going to be max piles, right? That's because that's the maximum number of. That's as fast as we can eat for each pile, right? Okay. So, also one more thing is that we know for sure that ours is going to be equal to the length of piles. Okay, so that means it always can be done. We can always eat all the bananas if we eat at the maximum number of items per pile. Okay, what are we going to do? All right. So we have left and right pointers, and now we can do a while loop. But before that, let's get some pointers. So minimum bananas per hour variables going. Let's say it's the currently max piles, or At this point, what else do we need? Let's see. I think that we're looking good here. So let's do left while left is less than or equal to right. We're gonna look for our midpoint. So mid is equal to left plus right divided by 2. Because numbers are so small, we can do that. So this is our bananas per hour. And with that, we can start eating the bananas. So for pile in piles, hours taken. So we need hours taken here every time we begin. Start at 0. And plus equals we need a map ceiling of the pile divided by the number of bananas per hour. So with that, we have hours taken. So if hours taken is greater than our hours h. So let's set that as maximum hours, maximum hours allowed is equal to h. If it's greater than, that means we don't record it, and we need to bring r down so that, well, we need to bring left up so we can eat more bananas. So left plus equals 1. Else, that means we were able to eat all the bananas within the time. So r minus equals 1. And we need to record our min bananas per hour equals the min between the previous bananas per hour and the current bananas per hour. And with that, we can return our answer, because once we've exited the loop, we have the minimum number of bananas per hour, and we did it in log n time because we were able to get rid of half the results each time we went through a loop. All right, great. So I think this was a nice practice of binary search. Hopefully I didn't mess up somewhere and we end up in an infinite loop. I'm pretty sure it looks pretty good from here. Oh, looks like we messed up somewhere. Okay, it looks like what happened was we have this timeline exceeded, and we have an issue here. So let's check it out. What's happening here? So I see. So it was not plus 1, it was equals mid minus 1, and I mean mid plus 1 and mid minus 1. I made a mistake here. Time limit exceeded, TLE. Right, it was the mid. So let's repeat it one more time. I think the results are going to be a little bit faster now. And that's it. Yeah, I don't really know exactly why. Sometimes it's a little bit faster, a little bit slower. I think it has to do with the problems that are given to the algorithm. But because of adding a single item left and adding a single item, reducing a single item left, what that would result in would be a that would not be a binary search. That would be what do you call those? A linear search, O of n time. So as you can see, the O of n time does not work for this particular problem, and we need the O of log n time to solve this problem, which is binary search. Okay, if you enjoyed this video, like, subscribe. Want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.